morning, ladies and gentlemen. My name is Bruce Champini. This is Etienne Calderon, and this is Antonio Simonis. We are OT2-FreeEnergy, and we are deciding to design and build a highway wind turbine. Our advisor, Dr. Basil. Now, we realize that wind does not always blow everywhere at the same time. However, we are trying to utilize the wind generated by moving vehicles on our highways to see if we can turn a small turbine generating electricity. We'd like to ensure that we do a Darius design, because this is much more efficient than a solenoid. However, we are probably going to combine both to see which is most, if we can have both combined to have a greater efficiency. Now, why do we look at this green energy project? Is because we're realizing, and we constantly hear about global warming and the effects that the production of CO2 from burning fossil fuels is causing on our environment. Now, this is the reason why we tried to see if we could develop this to reduce some of the costs in utilizing fossil fuels to generate electricity. Now, here is a before and after picture of Greenland, which is showing you what they say is the greenhouse effect. Now, in order for our wind turbine to work, the velocity is not a linear component of our equation, but it's a cubic. So velocity is most important. For the available wind power, we can see that's the velocity, cubic wind. And also, this is a growing trend where more and more people and countries are installing wind turbines, trying to harvest energy from that.
Our design consideration, what we're going to take in consideration in our design is the average wind speed of vehicles, noise, space, impact, environmental, and birds. And also, our design is going to be universal, that it can work any part, anywhere in the world, and compatible with any type of car. And also, we're going to label our design with different type of language, and label with some caution sign on it. That's our project timeline, with all the tasks on it, which are evenly divided. And our goal is like to have it done, our project done like 1 or 2 weeks before the due date. Is some of the major components we're going to use for our project. Those are some reasonable price we found so far, because we are funding ourselves and we still shopping around if we can find like some better price.
Okay, we did a design survey basically to figure out what's the best design for this project. And we looked at different parts of the world and what they were doing. There was a very good video on YouTube with some kids in India who actually developed highway wind turbines, pretty nice. But here's a design from China, wherein they have this grid system where you can put the pieces together. It's very cheap, it's about $100, but it doesn't look like something that's very safe, to me at least. But we'll have to investigate that some more. This is one proposed by an Arizona State University student, and he estimated that we can produce 9,600 kilowatts of energy per year with vehicles moving at 70 miles per hour. This was a rough SolidWorks. This is what we did right in the beginning to kind of model what we were going for. Of course, we're going to improve on that and do more simulations and analysis. This is data from the Global Wind Energy Council, which shows the amount of wind energy produced by country. China is leading the world. They also have the most vehicles. The United States is next, but it's less than 3% of energy in the United States. And in summary, we're going to be doing data collection so we can figure out the wind patterns of vehicles. We have to come up with a storage system for down times and slow times when we can't collect as much energy. And we want it to be able to be easily repaired and maintained. And of course, we would like a positive global and environmental impact.
Thank you.
Thank you. Any questions?
I'll go for it. Who's going to start? So we talked about this a little bit, but what are your exact applications that you're thinking of? So for instance, with this specific design, are you trying to power lights? Are you trying to add to the grid? What are
Both,
the
actually.
Okay.
We were trying to power the street lights, and maybe we could sell some energy back to the grid. We were thinking maybe, since we're moving towards electric cars, maybe we could have maybe we could somehow incorporate that.
So you should probably narrow it down a little bit. So try to think
Right.
about how much power you're actually generating. And so for instance, if you're going to hook this up to the grid, you want to make sure that the investment initially into hooking it up and adding additional cabling and everything like that is worth that investment. Otherwise, you can use it for lighting or whatever you want to do. But just make sure that the specific outputs that you have are relevant to your goals, I guess.
Could you describe a little bit more how you conducted your design survey?
We tried to go to the databases at FIU, and we couldn't find much information. In YouTube, we saw this video of some kids in India who actually came up with, actually they're right here. They came up with they had this design here, but ours is going to be a little bit different. But we looked at all around the world. We looked at different designs from all over the world.
But you just went to YouTube? Is that it?
No. We looked at, we went on Google Scholar databases everywhere, basically, to kind of find out. There's not a lot of people doing it, but we found at least 3 people that were doing like exactly something similar to what we want to.
Yes, sir.
How would you fit these infrastructure into the present infrastructure of the highway system without compromising safety of the highway system?
Good question. Actually, if you notice the first slide that you saw with the cars crossing on each side, we will be doing structural analysis on this to ensure that we're not going to find projectile when a car passes at a certain speed. Now, we're trying to put this in the median between both lanes of traffic, one on that side, one on this side, so we can receive drag on both sides. And I think we will generate more.
What if you don't have a median?
Well, if we don't have a median, we can put it on this side of the street. 8 meters away from a moving car, we have 3 to 5 miles per hour wind being generated. And
So you're basically saying you're going to restrict this then to highways, not all roadways?
Well, no. And that is the reason we came up with our Darius design. And we're trying to incorporate in that Darius design a solenoid. Now, we can accept wind from anywhere. It does not necessarily have to be a moving vehicle. Because a moving wind is going to create a lift on any one of these blades and turn our turbine whether cars are passing or not. Cars is just one thing that is going to give us more drag, generate more electricity.
So in a peninsula like Florida, then you would take advantage of the sea breeze from the Gulf and from the
Most
ocean,
definitely.
as well as vehicles.
Yes.
All right. You may want to include that in your report as well.
Any other questions?
Hey, number one, I'm very excited about the project. I like it. I mean, if you think about, just use the Palmetto Expressway as an example, how much energy we're wasting daily there.
That's a parking lot, man. What are you talking about?
Well, I'm going there right after that parking lot runs 24 hours a day, 7 days a week. So, but anyway, I look at your project plan and simulation time seems pretty short. Definitely your testing time seems really short. You mean it's like a week? My goal, I would propose that you work on this in such a fashion that you get your prototype done earlier, use your summer to your opportunity,
That's all.
and get some more simulation time. Definitely get some testing time planned in, so that you've got some real-time data. Simulation, real-time data, verify that they match. Have enough time that you can make adjustments if they don't match, to explain why. And that would make this more effective.
Okay, quick question. Are any of you?
Could you speak up a little bit?
Are you knowledgeable about electrical circuits? I mean, besides the class that you take here at school, have you been involved with some kind of electrical design type of work?
No. And hence our desire to consult electrical professionals to help us with the wiring and how all this works.
Yeah, because you're really looking at two different fields, mechanical and electrical.
Combined, yes.
Yeah, combined, yeah. Okay, I was just kind of wondering, because I figured out
No.
the mechanical. Have you thought about that?
Our main concern are like the blades and,
Structural integrity of this design.
right.